All right, let's get into some calculus involving polar curves. Specifically, what if we want slopes of tangent lines? All right. So if we have r equal to f of theta as our polar function, what we're going to do is we're going to convert that polar function to a set of parametric equations, and then we're going to apply our knowledge of parametric equations to find the slope of the tangent line. Okay, so if r is equal to f of theta, then x is going to be equal to, remember, it's r times cosine of theta for the x coordinates. This was when we were doing our conversions in the last video. So r is f of theta times cosine of theta, and y is going to be f of theta times sine of theta. And this is our set of parametric equations, the parameter being theta, that describe the polar curve. And now that we have that, we can go ahead and find the derivative, the period of that sentence, or rather find the slope of the tangent line by finding dy over dx. Now dy over dx is going to be dy over d theta divided by dx over d theta. And so now we can write all this out. We have a product rule here because f is a function of theta, and we're differentiating with respect to theta for each of these. So dy over d theta would take f prime of theta times the sine of theta plus f of theta times cosine of theta. That's our numerator. But I wouldn't necessarily, actually, I know for a fact, I would not memorize this like this. What I would do is I would just understand that we're doing dy over d theta divided by dx over d theta, and then calculate them in real time as I needed them, not like I'm demonstrating right now. That's wrong. So don't bother to memorize all of this. Okay. What you should be doing is understanding this part of it right over here, and then just doing the derivative work as needed in the particular problem. All right, so let's find the slope of the tangent line. Find the slope of the tangent line to the graph of, this is going to be r is equal to 2 minus sine of theta. You can go graph that. And we'll do this when theta is equal to 0 and theta is equal to 5 pi over 6. All right. If you understood what I've told you so far, go ahead and try it. Push pause, go work it out go as far as you can, and then see if it matches mine when you come back. All right, so x, when I convert this to the parametric equations, is going to be r, or f of theta, which is 2 minus sine of theta times cosine of theta. Y is going to be 2 minus sine of theta times sine of theta. Now we're going to go into doing some calculus here. Now you can simplify this first if you want. It might be a good idea to distribute. So you get 2 cosine theta minus sine theta cosine theta. For x and y is going to be 2 sine theta minus sine squared theta. That might be helpful, might not, I don't know. For you, personally. Now I'm going to need derivatives. So I'm going to need dx over d theta. So I might as well just calculate that now. So this is going to be negative 2 sine theta minus, and derivative of sine is cosine. So cosine theta times cosine theta. Don't forget the product rule here. Minus, take derivative of cosine, get negative sine theta sine theta. Be careful because we're subtracting here, so it's not 1. It's not cosine squared plus sine squared. This is a double angle formula for cosine if you recognize it, but if you don't, that's okay. You don't have to. You might just want to write minus cosine squared theta plus sine squared theta. When you distribute that subtraction on the outside, and just leave it like that. That's fine. You don't have to do anything more to it. Now, dy over d theta is going to be 2 cosine theta minus 2 sine theta times cosine theta. That's simplifying needed there. So if I want the slope of the tangent line, that's dy over dx. And so that's going to be this 2 cosine theta minus 2 sine theta cosine theta divided by negative 2 sine theta minus cosine squared theta plus sine squared theta. Now, resist any temptation to start canceling things out. And if something's really, really obvious and it cancels, then do so. There's nothing that cancels nicely here, so I wouldn't bother. Now, that's not actually the slope of the tangent line. That's just the derivative. Okay, if I want at x equals 0, what I want is dy over dx evaluated at x equals 0. By the way, notice I'm doing all this work without showing you the graph. I think maybe when I turn the recorder back on, you might have had a glance at the graph that was shown there for a moment, but you don't have to know what the graph looks like to do all this work. Okay, this is the calculus. This is how this works. Okay, we'll go back to the graph and make some sense of this in just a moment. But the slope of the tangent line here, dy over dx at x equals 0. Now we're just going to plug in. I'm sorry, this is at theta equals 0. Going too fast, writing and not thinking. Now we're going to plug in 0 for theta, and so cosine of 0 is 1, so we get 2. Sine of theta is 0, so in the numerator we just get 2. In the denominator, the two sine terms go to 0, the cosine term goes to 1, but I got a negative in front of it, so the slope here is going to be negative 2. All right, so we're going to go take a look at this in just a moment. I'm actually going to show you the equation of the tangent line, even though the question just asked for the slope. Okay, so if we look at the r is equal to 2 minus sine of theta. R of 0 is just going to be 2, so the polar coordinates here that we're looking at is 2, 0. The 2, 0 is in polar coordinates is also 2, 0 in rectangular as well. Okay, because you're just going 2 units to the right, you're not rotating at all, so you're going 2 units to the right, not moving up or down at all, and so that's the same coordinates. Okay, so the equation of the tangent line here, and again I'm using because I'm doing this in terms of x and y, let me write this under here. It would be y is equal to the slope, negative 2 times x minus 2 plus 0, which I'm not going to write. So let's go take a look at the graph. Here's the graph. It's kind of circular but squished up here at the top a little bit. Maybe it looks like a tomato. Now if I type in, by the way, in Desmos, if you click on the wrench over here, you could switch between different views. You could be in the rectangular view or the polar view like this. Okay, so I'm in the polar view over here, obviously. So we said y is equal to negative 2 times the quantity x minus 2. And look at that, tangent to the curve right there, just as we wanted. All right, so let's go do the other really quickly. We said the other problem is going to be at theta equals 5 pi over 6. So at theta equals 5 pi over 6, we want dy over dx evaluated at theta equals 5 pi over 6. This is going to take a little bit more calculation here. All right, so I'm going to do this mentally. If you want to go plug this into a calculator, you can. Hopefully I don't make any little mental errors, but you can follow along. 5 pi over 6 is in the second quadrant, so cosine is going to be negative, and the reference angle is pi over 6, so it's going to be root 3 over 2. So 2 times negative root 3 over 2 minus 2 times sine in the second quadrant is positive. It's going to be 1/2, and then negative root 3 over 2 here as well. And so this is going to be -2 for sine, so times a half, minus the negative √3/2 quantity squared plus the 1/2 squared. And so I'm going to cheat a little bit here, and this works out to be √3/3. If you do all the algebra here, I have that written down ahead of time. That's for speed. Now let's go graph the equation of the tangent line here again. So the polar coordinates for this is, r of 5π/6 is going to be 2 minus the sine of 5π/6. We said the sine of 5π/6 is going to be a half. So 2 minus a half is going to be 1.5 or 3/2. So the polar coordinates here are 3/2, 5π/6. And if I want to convert that over to rectangular, this is polar. We want rectangular, so we can graph this. I didn't do this ahead of time here. So, x is going to be r cosine theta. X is equal to 3/2 cosine 5π/6. So this is going to be 3/2 times -√3/2. So it's going to be -3√3/4. And the y coordinate is going to be 3/2 sine of 5π/6, which is going to be 3/2 times a half, which is going to be 3/4. All right, so if we did this right, our equation of our tangent line is going to be y equals the slope, √3/3, times x plus 3√3/4 plus 3/4 should be the equation of the tangent line here. So let's go type that in and see if we got it right. Y equals √3/3 x plus, I'm going to go back and look here, 3√3/4 √3/4. You guys are probably thinking, why doesn't he just pause it and type it in himself? Because I'm stubborn. And there we go. Tangent right there at 5π/6, which is exactly what we're looking for. All right, let's ask another question about this graph. It says, determine where the graph in the previous example, this type right there, has any horizontal or vertical tangent lines. This is common because they're not only testing you in your understanding of the polar relationships, but they're also testing your understanding of just vertical and horizontal tangent lines. And so if this is our slope of the tangent line, then we're going to have horizontal tangent lines. I'm just going to put horizontal here, where the slope is 0. So that means we need dy over d theta to be equal to 0. And we'll go solve that in a minute. For vertical, we're going to need to know where dx over d theta is equal to 0. And of course, we don't want both the numerator and denominator to be 0 at the same time, but that's what we're looking for. So what's dy over d theta? Sorry, I'm going to pause for a minute. All right, so dy over d theta we calculated way back up here. 2 cosine theta minus 2 sine theta cosine theta. So I already forgot it. It was 2 cosine. That's what I forgot. So we need to figure out where that is equal to 0. So we can factor out a 2 cosine theta from here, and we're left with 1 minus sine theta equal to 0. So we either have cosine theta equal to 0 or sine of theta equal to 1. All right, what is cosine equal to 0? That's what pi over 2, 3 pi over 2 all multiples of that, but we're not going to keep going. We're just looking at one revolution around the unit circle. When does theta equal, I'm sorry, sine of theta equal to 1? That's going to be at pi over 2. All right, so we have two different ways that this can happen, either with theta is pi over 2 or 3 pi over 2. I'm just double checking that all this makes sense. Okay. So what are the coordinates of the point? So remember, r is equal to 2 minus sine of theta. So r of pi over 2 is going to be 2 minus the sine of pi over 2, which is going to be 1. And r of 3 pi over 2 is going to be 2 minus sine of 3 pi over 2. Sine of 3 pi over 2 is negative 1, so 2 minus negative 1 is going to be 3. So the points where this is going to happen in the polar plane is going to be 3 comma 3 pi over 2 and 1 comma pi over 2. To be honest with you, I'm not sure how Desmos plots polar points. If it does, we have to convert these, I think, to rectangular. So let's do a little conversion here. We're going to convert to rectangular. So the x coordinate is going to be 3 r times cosine of theta. So 3 times cosine of theta. Cosine of theta is going to be 0. So 0. Y is going to be 3 times sine of theta. Sine of 3 pi over 2 is negative 1, so it'll be negative 3. And then over here, again, cosine is going to be r cosine theta. That's still going to be 0. And then for the y coordinate, it's going to be r times the sine. So 1 times 1, which is 1. So let's go plot those and see if they are actually locations of horizontal tangent lines. So if I plot 0 comma negative 3, notice right down over here, okay, graph does have a horizontal tangent line right there. So even I can plot even y equals negative 3, and it'll go right to the graph there. And the other one we said was going to be at 0, 1. So 0, 1, you can see that there. We can plot y equals 1, and that goes right to the graph horizontally there as well. Now we need the vertical tangent line. So let's go back. And for the vertical tangent lines, we had, I need d theta, dx over d theta. So minus 2 sine theta, negative 2 sine theta, minus cosine squared theta plus sine squared theta is equal to 0. So let's get everything in terms of theta. So minus 2 sine theta minus 1 minus sine squared theta, that quantity plus sine squared theta is equal to 0. Now if I distribute, I'm going to end up with a positive sine squared theta and another sine squared theta, so I'll have 2 of those, 2 sine squared thetas, minus that 2 sine theta, and then minus 1 is equal to 0. And unfortunately, this does not factor nicely. So here we're going to have sine of theta is equal to, I'm going to do the quadratic formula. So 2 plus or minus the square root of b squared, so 4 minus 4ac, 8, negative 8, so plus 8, all divided by 4. This is 2 plus or minus root 12 over 4. Or 2 plus or minus 2 root 3 over 4, or 1 plus or minus root 3 over 2, if you want to simplify it, sorry. I guess I wanted to simplify it. So I got two values for sine here. Sine is going to be 1 plus root 3 over 2, or 1 minus root 3 over 2. But if you know anything about root 3 over 2, about root 3, root 3 is bigger than 1. In fact, it's bigger than 1.5. Yeah, because 1.5 squared is 2.25, so it's bigger than 1.5. Add 1 to that, it's going to be bigger than 2.5. Divide by 2, and you're going to get something bigger than 1. So there's no solution here. Now 1 minus root 3 over 2, there are solutions there. We're going to need to use some inverse or inverse trig functions. This is going to be negative, and so sine could be negative over in the third and the fourth quadrants over here like this. And so this is more involved than I wanted it to be. I'm just going to jump to the answers. Theta is going to be about 3.51 or about 5.91. And if you need help working those out, come see me in office hours. I just don't want to take the time to do that right now. This video is long enough already. So let's go back over here really quickly. Right up here. So I'm gonna do this more mechanically here. So 2 minus sine of that first value, 3.51, comma. That's our all of that. I'm going way too fast here for a moment. That's r. And so I need to multiply that by cosine of theta to get the x-coordinate. So cosine of 3.51, then 2 minus sine of 3.51, and sine of 3.51. And that gives us our coordinate right here. And you can see that we have a vertical tangent line there. And so if I set x equal to the x-coordinate that I typed in over here, cut and paste that down into here, you can see it's vertical. And the other one, another set of parentheses, 2 minus sine of 5.91 times the cosine of 5.91. 2 minus sine of 5.91. So we get our other point way out here. You can see that one's going to give us a vertical. X equals Control C. We'll get that plotted over there. We'll get that vertical line. And there it is. We did it correctly. All right, ladies and gentlemen, go study.